Good day, everybody. Once again, we are back together. And as I said, I'd be looking at maths past exam questions here. If you haven't subscribed, please just make sure that you're part of the family. And of course, for those of you who need assistance, we've got all our information, in the description of this video. All right, so we're going to be looking at question 2 from the May-June exam of 2021. So let's get right into the question. This is based on sequences and series. Right, now the first question, they say to us, consider the quadratic sequence. So we've got 72, 100, 120, and 132, right? So they say to us, determine Tn, the nth term of the quadratic sequence. Now, just a couple of things. Of course, we have gone through this. You can look at the full lesson on how I actually just presented on the quadratic sequence. So what we're going to do is we're going to start, first of all, we know that the general expression for the quadratic sequence is an squared plus bn plus c. Okay, so what we are going to do is we're going to try by all means to get the value of a, b, and c so that we get that nth term of the expression as they have said. Right, so now what is our sequence? So we've got our first term to be 72, we've got 100, we've got 120, and we've got 132, I think. Okay, right, so now we find our first difference. Okay, so in this case, remember, we find the difference by taking term 2 minus term 1. Okay, so 100 minus 72, that will give us 28. 120 divided by 100, that will give us 20. Okay, and 132 subtract 120, that will give us 12. Okay, so that's our first difference. Now, of course, we're going to try and find our second difference in this case. So we're going to say, so 20 subtract 28, 20 minus 28 will give us negative 8. And of course, 12 minus 20, that will also give us minus 8. And remember, in our second difference, that is where we'll have a constant difference or a common difference. Right, so what we do with the arithmetic sequence, quadratic sequence rather, is that we always the second difference, you just simply say 2a is equal to the value of your second difference. Okay, so that's equal to negative 8. Okay, so to get the value of a, I'm going to just divide both sides by 2 there, and therefore a would be equal to negative 4. Right, now to get the value of b, what we do is that we go to the second difference, the first difference. So we took the second difference and we equated it to 2a. And then now remember that the first difference is simply 3a plus b. So we say this is equal to 2a, this is 3a plus b, and we know that this is going to be a plus b plus c. Okay, just keep that in mind, right? So now to find the value of b, what you're going to simply say is 3a plus b is equal to the first term of our first difference. This is equal to 28. Okay, so we know the value of a is already negative 4 plus b. This is equal to 28, and of course, solving for this, 3 times negative 4 will give us negative 12. But if we take it to the other side, it becomes positive 12. So in this case, we've got 28 plus 12, and that will give us 40. So our b value is 40. And then obviously to get c, we said you go to the first term of your quadratic sequence and you simply say a plus b plus c will be equal to that first term. So in this case, we're simply going to say a plus b plus c. I'm really not going to exhaust that much time trying to show you where this comes from. Of course, if you want to look at that, you're going to go into the video that we made, the full lesson on this particular section. Right, so a plus b plus c equal to 72. Okay, so I've got a as negative 4, and we got it there. We've got b as 40, and we've got c as we want the value of c rather. So this is equal to 72. So in this case, we've got minus 4 plus 40. In this case, that will, in fact, let's just take everything to the other side. So we're going to have that 72 plus 4, so that becomes positive. Okay, so this is minus 40. So 72 plus 4, that will give us 76. Minus 40, that will give us 36. Okay, so C is equal to 36. All right, now let's write the expression in full. So it means that our nth term of this sequence is simply going to be negative 4n squared, okay, plus 40n, okay, minus plus 36. Yeah, we've got C as positive 36. All right, so that is our expression for our quadratic sequence. Okay, right, now let's go to the next question. In this case, what we're going to do is look at 2.1.2. okay, so we answered 2.1.1. all right, now they say to us a term in the quadratic sequence is equal to the 12th term of the sequence of the first difference. All right, so determine the position of this term in the quadratic sequence. Now I want you to understand very clearly, right? So let's look at the first difference. So remember, our first difference is this expression here, which is 28. So the first term is 28, the second term is 20, and the third term is 12. And what is the common difference between that? It is negative 8. You remember we got that, right? So in this case, what they are saying is that now, which term in the quadratic sequence will be equal to the 12th term, right, of this first difference. Okay, so we need to now find what is the 12th term of that first difference. So what I'm going to do is that now we're going to look at our first difference. Now you remember our sequence in the first difference, so this is 2.1.2. so our first term in that sequence was 28, and then following 20, and then we had 12, right? So we found the common difference to be negative 8. So that makes it an arithmetic sequence. Why? Because it has a common difference. Okay, in this case, so we know that the 12th term, okay, if it's a arithmetic sequence, we know we're going to say a plus 11d, right? So again, if you don't know what I'm talking about, you're going to go and look at our video on sequences and series, and in particular the arithmetic sequence. And so this is going to be a plus 11d. Okay, now in this case, our a value we know is 28. Okay, so that's 28 plus 11 times our common difference is negative 8. So what we actually have there, so that's 28 minus 88, okay, and that will give us negative 60. Now we want to know in our quadratic sequence which term will be equal to minus 60. Okay, so what we're going to do is, we know in our quadratic, the expression for our quadratic sequence is negative 4n squared, right, plus 40n plus 36, okay, and this will be equal to negative 60. All right, so now we're going to solve that. So we're going to say minus 4n squared plus 40n. Okay, now I'm just simply going to bring this minus 60 to the other side, so that I have a 0 on the other side. Okay, so that becomes positive. So 36 plus 60, that will give us 96, and this would be equal to 0. Now, of course, let's just divide everything by negative 4. All right, so if I divide this term by negative 4, I'm left with n squared. Okay, and this changes to a negative. Remember, I'm dividing by a negative number, so every sign changes, right? So this will be 40 divided by negative 4 will give me negative 10, so that's minus 10n, and of course 96 divided by 4, this will give me 24, right? But it also changes sign, so that's minus 24, which is equal to 0. Now let's try and factorize which factors of 24, which are the factors of 24 in this case, such that when I subtract them will give me 10. I think that will be 12 and 2. So I'm going to open up two brackets there. So I'll have n and n. I'll have 12 and 2. Now I want you to please note we are trying to make the middle term negative. So our bigger product will have to be negative. Our bigger product is 12n. So that means this will be negative. And of course, this will be positive. Okay. So in this case, n is equal to 12 or n is equal to negative 2. And of course, this is a function of natural numbers. So it means this value will actually not be applicable. So it means that it's our 12th term that will be applicable in that case. Okay. Right. So let's continue. All right. So let me try just to move this around. Okay. I always try that, so that it's much easier for us to just navigate through the questions. All right, now the next question, they said to us, determine the maximum value of this quadratic sequence. Okay, so we want the maximum value. Now remember, in this case we already have an expression for the quadratic sequence. It's Tn, which is equal to minus 4n squared, okay, plus 40n, all right, plus 36. Now, how do we get the maximum value? I'm sure some of you are already thinking, maximum value for a parabola. What we are simply going to do is that we are going to take the derivative. Another way that we can do that is if we take minus b over 2a, but I'm just simply going to take the derivative and make it equal to 0. So I'm going to take t dash of n, okay, in this case. So that's our term. So that will be minus 8n. So 4 times 2, it's minus 8n plus 40. And this is equal to 0. Remember, for maximum value, we always take the derivative and make it equal to 0. So in this case, we get... so we've got minus 8n is equal to negative 40. And if we divide both sides by negative 8, okay, our n value would simply be equal to 5. But remember, we're not looking for the term number. We're looking for the maximum value. So in this case, it means that what I'm simply going to do, I'm going to simply say, well, T5, okay, that would be, now I'm going to substitute n is equal to 5 to the original expression. So that's minus 4 times. So everywhere I see n, I'm going to put 5. So that's 5 squared plus 40 times 5 plus 36. Okay. Right, so in this case, what do I have? That would be minus, that's 5 squared is 25 times 4, that would be 100, so that would be minus 100, plus 40 times 5, that will give us 200, plus 36, and I get a value of 136. So obviously, in this case, it means that our maximum value in this case would be in the fifth term, which is equal to 136. I hope that makes sense, ladies and gents. All right, now the next question, they say to us, determine the maximum value of the sequence. Okay, so they give us the sequence there. So that will be, now let me just do something here. So if you look at that sequence, let's take the the constant difference there. So if I say 5 minus a negative 23, that will give me 28. If I say 25 minus 5, that will give us 20. And of course, if I say 37 minus 25, in this case, that would give me 12. Okay, so in this case, can you see that the second difference is exactly the same as the second, or rather the first difference is exactly the same as the first difference of our previous sequence in this case. So once again, it's a quadratic sequence, so it means that the maximum value as well will be on the fifth term, right? So what would be our fifth term in this case? I want you to please note. So if you think about the next term of the sequence, now you can see the second difference is well decreasing by 8, negative 8. So meaning that the next term of your your first difference in this case would simply be, so you'd say 12 minus 8. So it means that our second, or rather first difference, the next term would be 4. So if I now want to find the fifth term, right, I would simply say, okay, so we are going to take 37. Okay, so I'm going to take 37 plus 4 in this case, and that will give us 41. So that means that the maximum value, so that would be 2.1.4. So the maximum value in this case, 2.1.4. So it means that the maximum value would be equal to 41. Okay, I hope that made sense. It was a 1-mark question, so it means that we were not really supposed to do much in terms of working out. All right, now on the last question, they say consider the sequence negative 11 plus 2 sine 3x and 15. Okay, so those are the terms of the sequence, term 1, term 2, and term 3. They say determine the value of x in the interval 0 to 90 for which the sequence will be arithmetic. Now, let's write down, so that's 2.1.5, right? Or 2.2 actually. Okay, so that's 2.2. So let's now write down the terms of the sequence. Remember, they said that's minus 11. They said we've got 2 sine of 3x, and we've got 15. Okay, so what are we going to do? Remember, they wanted it to be an arithmetic sequence. All right, so what does that mean? It means if it's an arithmetic sequence, it has a common difference, right? So what does that mean? So if this is term 1, this is term 2, this is term 3, so what's going to happen is, we know that term 2 minus term 1, okay, that's what a common difference is, should be equal to term 3 minus term 2. Okay, hope that makes sense. So in this case, what is our term 2? That's going to be 2 sine of 3x, okay, minus term 1, so that's minus a negative 11. Okay, and our term 3, we said that's 15, okay, minus 2 sine of 3x. Okay, right, so in this case, what do we have? We've got 2 sine of 3x plus 11. Okay, remember, negative times a negative would be a positive, and this would be equal to 15 minus 2 sine of 3x. Okay, now let's group all our like terms together. So I've got 2 sine x, I've got minus 2 sine x. If I take this to the other side, it becomes positive. So I've got 2 sine 3x plus 2 sine 3x, which will be 4 sine of 3x. Okay, and in this case, I've got 15 positive. If I take the 11 to the other side, it becomes negative. So in this case, it becomes 15 minus 11, which would give me 4. So what I can do in this case, I can divide both sides by 4. Okay, so I've got sine of 3x. Okay, 4 divided by 4 gives us 1, is equal to 1. So now let's try and solve that. Okay, so we know that 3x is equal to the arcsine of 1 and not negative 1. So arcsine of 1. Okay, and in this case, it means that will give us 90. Okay, So 3x is equal to 90. Okay, but we remember in this case, when you give a general solution, this is going to be plus k 360. Okay, k 360, where k is an element of integers. But we're not looking for the general solution. In this case, we're looking for a specific. They've given us an interval between 0 and 90. So we divide by 3. Okay, so if we divide by 3, remember we need to divide also that by 3. Okay, so it means that x is equal to 30, okay, plus k 120. Okay, so that is our solution. However, in this case, because they've given us an interval, we need a specific value for x, right? We're not looking for the general solution, but a specific value for x. So in this case, what will fit the restriction? 0 to 90. And by the way, if you said 180 minus 90, which of course this is sine, you always give the reference angle and 180 minus that reference angle. And in this case, you would have still gotten 90. So that's why I didn't bother much with it. Okay, so what I'm going to do is, okay, so there's nothing that we can substitute here. So if we say k is equals to 0, k is equal to 0. So we've got x is equal to 30 plus 0 times 120. Okay, so does that fit the restriction? So our answer is equal to 30. Okay, that works. If we say k is equal to 1, okay, x is equal to 30 plus 1 times 120. Okay, so now that would give you 150. That is outside of that restriction that you are given. And if we also use k is negative 1, so x would be equal to 30, all right, plus, so that would be negative 1 times 120, okay, and in this case, what you would get there is negative 90, and of course that does not fit the restriction. So it means the only solution that we have there is x is equal to 30. All right, ladies and gents, I hope that made sense. Even though I'm in a bit of a noisy background there, I've got a bit of a noisy background, but I hope that you were able to truly understand and appreciate sequences and series. I think you've got a real opportunity to get free marks here. I hope that you understood. But of course, if you're still struggling a little bit, please go and watch our videos. But of course, you can always join our classes that we have on a weekly basis. Okay, you can get them, using the details that we have on the description of this video. Otherwise, I'll see you guys again next time. Shap shap.